So students, welcome back. Today we are starting new chapter, mechanical properties of solids. Sorry, what is the chapter name? Mechanical properties of solids. So good evening all of you. Aaron, Nandana, Abhinav, Sri Shakti, Abhishek, Sanusha, Jishna, Vijusha, Shada, Nikhil Rajan, Arjun Krishna, Anila, all of you, good evening. All of you, good evening. So our next chapter is mechanical properties of solids. So it's a very easy chapter. It's a theory chapter. So you have to note it down. ഒരുപാട് എഴുതിയെടുക്കാനുണ്ട്. Mechanical properties of solids. First of all, what are the properties of solids? Solids have definite size and shape. Solids can be crystalline or amorphous. Crystalline means what? Solids which have regular structure are called what? Crystalline. If it is not having a regular structure, no regular structure, then it is called what? Amorphous. Correct or structure ആയിട്ടുണ്ടെങ്കിൽ അതിന്റെ പേരെന്താ? Crystalline solids. അങ്ങനെ regular structure ഇല്ല എങ്കിൽ it is called amorphous solids. The density of solids is slightly higher than liquid state. So solids will have more density as compared to liquid state. Now, elastic behavior of solids. Solids are not perfectly rigid. What is a rigid body? That we have seen before. If distance between particles of a body do not change even after application of a force, we call it a rigid body. What is the specialty of rigid body? Distance between particles of the body do not change even after application of a force. നമ്മളൊരു ഫോഴ്സ് അപ്ലൈ ചെയ്തിട്ടും ഡിസ്റ്റൻസ് ബിറ്റ്വീൻ പാർട്ടിക്കിൾസ് മാറുന്നില്ല എങ്കിൽ we call them a rigid body. A rigid body generally means a hard solid object having definite shape and size. So that is the first thing about rigid body. A hard solid object having definite size and shape. But in reality, practically നോക്കുമ്പോൾ solids can be stretched, compressed and bent. Solid bodies are not perfectly rigid. Solid bodies, is it perfectly rigid? No. Solid bodies in reality can be bent, it can be stretched, it can be compressed. So solids are not perfectly rigid body. Next, elasticity. The property of a body by virtue of which the body tends to regain its original size and shape when the applied force is removed is known as elasticity. See, suppose I am taking a steel rod and I am hitting the steel rod. What happens? When the applied force is removed, the steel rod will be in its original size and shape. So steel is elastic. See, there is a problem. Students, when they hear about elastic body, they will think about elastic property. That is wrong. What is elastic property in physics? If body comes back to original size and shape, when the applied force is removed, we call that body an elastic body. And the property is known as elastic property. Remember, steel is more elastic than rubber. The harder the substance, the more elastic it is. So, it's better to conclude that the harder the substance, the more elastic. So, steel is diamond, more elastic than steel, which is more elastic than rubber. Diamond is the hardest substance. That is elasticity maximum for diamond. Elasticity maximum for diamond. Listen, മക്കളെ ഇത് വെറും തിയറി ചാപ്റ്റർ ആണ്. മാഷ് പഠിപ്പിക്കുമ്പോൾ ഒപ്പം പഠിക്കുക, നോട്ട് ചെയ്യുക, അതിൻ്റെ ഒപ്പം പഠിച്ചു പോവുക. വളരെ സിമ്പിൾ ആണ്. ശ്രദ്ധിക്കുക, the property of a body by virtue of which it tends to regain its original size and shape when the applied force is removed is known as elasticity, and the deformation formed is called elastic deformation. Example, steel is an elastic body. Steel is what body? Elastic body. മനസ്സിലായോ? അപ്പൊ എല്ലാവരും നോട്ട് ചെയ്യട്ടോ, എല്ലാവരും നോട്ട് ചെയ്യാട്ടോ. What about others? All of you done? Noti Vegam. Noti da. Then next, plasticity. The body The body which has no tendency to regain its original size or shape and gets permanently deformed is called a plastic body. This property is known as plasticity. This property is known as plasticity. And the deformation formed is called plastic deformation. What is mean by plastic? Here body does not come back to original size and shape. What is the specialty here? Body does not come back to original size and shape. Example for this, clay and wax. You know clay modeling, no? What happens in clay modeling? We'll be applying a force and on the clay and we will be forming different shapes. Now after the force, after the shape is formed, when the applied force is removed, will the clay come back to original shape? No, it will remain in that new shape. So it is having what property? Plastic property, because it has no tendency to go back to initial state. Another example is putty that we paste on the walls, no, to make it wall smoother. Once that putty is pasted and one that Malayalam കൊലരെന്ന് പറയും ആ കൊലരെടുത്ത് കഴിഞ്ഞാൽ will it come back to original position? No, it will remain in the same shape. That means what? Plastic property. Note here. Next, stress. A force which changes length, shape or volume is called a deforming force. What is deforming force? A force which changes length, shape, volume are called what? Deforming force. A force which changes length, shape and volume are called deforming force. Done. Next. Next, when an elastic body is stretched to a deforming force, a restoring force. What is a restoring force? A force which brings back the body to original size and shape or initial state is called a restoring force. Is developed in the body. This restoring force is equal in magnitude but opposite in direction. See, when I apply force on my body, this is called what? Applied force. Then muscles will get expanded. But when the applied force is removed, there will be restoring force, which is what? Equal in magnitude but opposite in direction to the applied force. The restoring force per unit area, restoring force per unit area is known as stress. If F is the applied force, A is the area cross section, then what is stress? Force by area. The SI unit of stress is Newton per meter square or Pascal. Dimensional formula ml raised to minus 1 T raised to minus 2. The restoring force per unit area is known as stress. If F is the applied force and A is the area cross section, then stress is equal to force by area. SI unit of stress is Newton per meter square or Pascal. Dimensional formula ml raised to minus 1 T raised to minus 2. So this was about stress. Please note it down. Note here. Restoring force per unit area is known as stress. Note it down. Next, types of stress. First one, linear stress, another name longitudinal stress, another name tensile stress. It is a stress developed in the body when the applied force produces change in length. What is linear stress or tensile stress or longitudinal stress? When the applied force produces change in length, we call it as what? Linear stress. Next, volume stress, another name is bulk stress. It is a stress developed. It is the stress developed in the body when the applied force produces change in the volume of the body. Next is shearing stress or tangential stress. It is a stress developed in the body when the applied force produces change in shape of the body. Change in shape of the body, tangential stress. Change in volume, bulk stress. Change in shape, shearing stress. Another name is what? Tangential stress. Shearing stress, another name is what? Tangential stress. So these are the different types of stress which is very important. Note here, important എന്ന് ഞാൻ പറയില്ല, അറിഞ്ഞിരിക്കണം. What are the different types of stress? Linear stress, another name tensile stress, another name longitudinal stress. ലൈൻ കറക്റ്റ് ആയിട്ട് വന്നിട്ടില്ലല്ലോ. നോട്ട് ചെയ്യട്ടോ. Next, strain. Let's see strain. The deforming force applied on a body produces generally change in its dimension and the body is said to be strained. Strained means വലിഞ്ഞിരിക്കുന്ന അവസ്ഥ. See, in Bahubali movie, the hero Prabhas stretches the arrow like this. So arrow is under a strained state. The deforming force applied on a body produces generally change in its dimension and the body is said to be strained. Strain is defined as the ratio of change in dimension to original dimension. What is strain? Ratio of change in dimension to original dimension. If the deforming force produces change in the dimension, then the body is said to be strained. What is strain? Change in dimension by original dimension. Not a strain. Yeah, next. Next, different types of strain. Strain is what? Change in dimension by. Strain is what? Change in dimension by original dimension. Strain has no unit and no dimension. Strain has no unit, no dimension. What are the different types of strain? Longitudinal strain. If the deforming force produces change in length, the strain produced in the body is called what? Longitudinal strain or tensile strain or linear strain. What is longitudinal strain? Change in length by original length. Change in length delta L. See, this was original length. Now, due to longitudinal strain, what happens? New length is what? Original length plus delta L. What is delta L? Change in length. So, what is longitudinal strain? Change in length delta L by original length L. Remember, change in dimension divided by original dimension. So, strain does not have a unit, does not have a dimensional formula. Strain endilla, no unit, no dimensional formula. Note it down, strain and longitudinal strain. ഫിഗർ വരയ്ക്കണേ. ഫിഗർ വരയ്ക്കണം. ഒറിജിനൽ ലെങ്ത് L, ചേഞ്ച് ലെങ്ത് L പ്ലസ് ഡെൽറ്റ L കാണിക്കണം. So strain is what? Change in dimension by original dimension. Next, volume strain. Next strain is volume strain. Let's see volume strain. It is the deforming, if the deforming force produces change in volume, the strain produced in the body is called what? Volume strain. So what is volume strain? Change in volume by original volume. See, suppose there was original volume V. Now a force is applied on it. So what happens? Because of this force, the volume is reduced. So this change in volume is what? Change in volume is what? Delta V. So what is volume strain? Change in volume by original volume. See, remember both are volume. So no unit, no dimensional formula for volume strain. Next is shearing strain. See, there was a body here, cylinder, and I am applying a force only on the top of the body. So from the initial position, it has changed what? Delta X. So what is shearing strain? Shearing strain is tan theta. What is tan theta? Opposite side by adjacent side. What is opposite side? Delta X. What is adjacent side? L. So what is tan theta? Delta X by L. But for small angles, instead of tan theta, we can take theta as shearing strain. So what is theta? Delta X by L. Delta X is the change and the adjacent side is what? Original length L. So what is shearing strain? Tan theta or theta equal to delta X by L. What is shearing strain? If the deforming force produces change in shape, then the body is said to be change in shape of the body without change in the volume. So what happens in shearing strain? There will be change in shape of the body without change in volume. The strain produced is called what? Shearing strain. Change in shape of the body without change in volume. It is called what? Shearing strain. നോട്ട് ചെയ്യട്ടാ. രണ്ടും നോട്ട് ചെയ്യും. വോളിയം സ്ട്രെയിൻ രണ്ടും നോട്ട് ചെയ്യും. Note ചെയ്തില്ലേ? Then continuing. Next, Hooke's law, which is the most important topic of this chapter. Hooke's law. It is very, 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 very important. Hooke's law. What is Hooke's law? Hooke's law. According to Hooke's law, within the elastic limit, stress is directly proportional to strain. Within the elastic limit, stress is directly proportional to strain, or stress by strain equal to a constant. Stress by strain is equal to a constant. That constant is called modulus of elasticity. That constant is called what? Modulus of elasticity. Constant K equal to stress by strain. So what is Hooke's law? Within the elastic limit, stress is directly proportional to strain. Stress by strain equal to constant. That constant is called what? Modulus of elasticity. Modulus of elasticity depends on nature of the material of the body and temperature. Modulus of elasticity depends on what? Nature of the material of the body and temperature. Modulus of elasticity is independent of dimensions like length, volume of the body. SI unit of modulus of elasticity is Newton per meter square or Pascal. SI unit of modulus of elasticity is what? Newton per meter square or Pascal. Note here, Hooke's law. Within the elastic limit, stress is directly proportional to strain. Stress by strain equal to a constant. Constant called modulus of elasticity. Hooke's law is a very, 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 very important topic. Hooke's law note ചെയ്താ. Hooke's law വളരെ important ആണ്. Hooke's law is very, very important. Those who have finished writing down, please try to study from the class itself. Because it is a 100% theory chapter, very easy chapter. So, പഠിച്ചു കഴിഞ്ഞാൽ എഴുതി കഴിഞ്ഞാൽ അപ്പം തന്നെ ഇരുന്ന് പഠിക്കുക. Next is stress strain curve, which is a sure question for Kerala board exam and also for entrance also. It's a repeated question. Stress strain curve for a metal. See, what is stress strain curve? First of all, most important point is that on x-axis we have strain, y-axis we have what? Stress. Y-axis we have stress and x-axis we have what? Strain. Now, suppose on the ceiling a metallic wire, a copper wire is hanged. It is hanging with a hook, and I am adding weight to this hook. What happens? Weight means what? Stress is increased. That means what? There will be corresponding strain. So first of all, you should note OA region. What is OA region? OA region is proportional region. What is a proportional region? Hooke's law is obeyed. Proportional region means Hooke's law is obeyed. Hooke's law obeyed. That means what? Stress is directly proportional to strain. So the more the stress, more will be the strain. Not only that, once this load is removed, നമ്മൾ ഈ വയറുമഞ്ഞാത്തിരിക്കുന്ന ലോഡ് റിമൂവ് ചെയ്താൽ, once the load is removed, the body comes back to original size and shape. That is a specialty here. Once the load is removed, body comes back to original size and shape. That is a specialty of OA region. Proportional region. Hooke's law is obeyed. Stress is directly proportional to strain. Next region is what? AB. See, so what is A? Point A is called proportional limit. Point A is called what? Proportional limit. Up to point A, stress and strain are directly proportional. Next is OAB. Now, what is this AB? AB region is not proportional. AB region stress is not proportional to strain. So what is OAB? OAB region is elastic region. In the OAB region, elastic property is there. That means what? Body comes back to original size and shape when the applied force is removed. But you should note the difference. OA region stress is directly proportional to strain. But in AB region, stress is not proportional to strain. Stress is not proportional to strain. Not proportional to strain. Stress is not proportional to strain. Still, body comes back to original size and shape. Original size and shape. So it is what nature? So it is elastic nature. Elastic nature in the region OAB. So OAB region we have what property? Elastic property. Now after point B, so B is what? Elastic limit. See, let me tell you, this is very, very important. Why it is called elastic limit? Because up to that point, elastic property is exhibited by the body. What is elastic property? When the applied force is removed, body should come back to original size and shape. That is elastic property. But after point B, what happens? If the load is increased further, if you are increasing more weight, what happens? Body does not come back to original size and shape. Once the load is removed, body is not going through the original path. It is going through new path. Body is said to be permanent set. Because this wire will be permanently stretched. Body wire does not go back to original size and shape when the applied force is removed after point B. So there is a limit for your, there is a limit to which a wire can be stretched. A wire can be at a load. If it is beyond that load, what happens? Wire gets permanently stretched, or you can say permanently damaged. That is the point C marked in the figure. Now, very important, after point C, what happens with reduced stress? Stress is only this much, but there is a large strain. After point C, even with less stress, large strain. So, is Hooke's law is obeyed? No. So, after point B, this behavior is called plastic behavior. Why plastic behavior? If the body comes back to original size and shape, elastic behavior. But after point B, what happens? Body has no tendency to come back to original size and shape. So, it is not elastic behavior, it is plastic behavior. So, B is called elastic limit. Another name for elastic limit is yield point. Then D, point D. Point D corresponding stress is called ultimate tensile strength. Ultimate tensile strength. Ultimate tensile strength. So, after point D, what happens? What is the funny thing here? Even with reduced stress, you are not applying any load, still the wire gets stretched. After point D, see it is going downwards means what? Stress is reduced, but still x-axis strain is getting increased. So with the reduced stress, again strain is increasing, and eventually fracture occurs at point E. So E is called what? Fracture point. The wire gets broken. That is fracture point. If D and E are closer, that means what? It easy to break. Such materials are called brittle material. If D and E are far apart, we call them ductile. If D and E are closer, D, E closer, brittle material, example glass, brittle material, example glass. If D and E far apart, ductile material, example gold. So this was about stress strain graph. Please note it down. It's a very important graph. Note it up. ഭയങ്കര important. Elastic region OAB graph is very, very, very important. Many times when I evaluate answer paper, elastic, what is OA? Proportional region. What is OAB? Elastic region. What is A? Proportional limit. What is B? Elastic limit or yield point. What is D? Ultimate tensile strength. What is E? Fracture point. If D and E are closer, brittle. If D and E are far apart, ductile. Then after point B, between B and D, material is having what behavior? Plastic behavior. എല്ലാവരും നോട്ട് ചെയ്തെന്ന് വിചാരിക്കണം. ഇനി നമുക്ക് we will see each and every line. The above curve is a typical stress strain curve for a metal. Note ചെയ്യണേട്ടാ, please note these lines. The above curve is a typical stress strain curve for a metal. The stress strain curve may vary from material to material. Okay, so the figure we have drawn is what? Stress strain curve. In the region OA, the curve is linear. So each region is noted. In a region OA, curve is linear. In this region, Hooke's law is obeyed. The body regains its original dimensions when the applied force is removed. In this region, the solid behaves as an elastic body. In the region AB, stress and strain are not proportional. I told you, stress and strain are not proportional. Still, the body returns its original dimension when the applied force is removed. The point B in the curve is known as elastic limit, another name yield point. and the corresponding stress is known as yield strength, SY, of the material. If the load is increased further beyond the elastic limit, the body cannot regain its original size and shape. In the portion of the curve between C and D, if the load is increased, the strain is increased rapidly even when for a small change in stress. After point B, what happens? Strain is increased even for a small increase in stress. When the load is removed at some point C, say at C, what happens? Between B and D, നമ്മൾ അപ്ലൈ ബി എന്ന് പറഞ്ഞ പോയിന്റിന് ശേഷം സി എന്ന് പറഞ്ഞ പോയിന്റ്, ആ സി എന്ന് പറഞ്ഞ പോയിന്റ് എവിടെയാണ് വരുന്നത്? ബിറ്റ്വീൻ ബി ആൻഡ് ഡി, വി ആർ റിമൂവിങ് ദ അപ്ലൈഡ് ലോഡ് അറ്റ് പോയിന്റ് സി. വാട്ട് ഹാപ്പൻസ്? The body does not regain its original dimension. The material is said to have permanent set. Material is having said to what? Material is said to have, the material is said to have what? Permanent set. And the deformation produced is known as what? Plastic deformation. And the deformation is said to be what? Plastic deformation. The point D on the graph corresponds to ultimate tensile strength of the material that we have noted earlier. The ultimate tensile strength. Please note down this. It's an explanation of the graph. Please note down. It is very important. Listen, in most of the question paper, you can explain stress strain graph, explain Hooke's law. These two are the most important repeated question from this graph, from this chapter. I hope you have noted down. Next, the deformation is said to be plastic deformation. The point D on the graph corresponds to what? Ultimate tensile strength ratio of the material. Beyond point D, we have seen in the graph after point D, additional strain is produced even by a reducer applied force. So even when stress is reduced, strain is increasing. Even when the applied force is reduced, still strain is increased and eventually fracture occurs at point E. So point E corresponds to fracture point. Note, if the ultimate tensile strength and fracture point, that is point D and E, are closer, material is said to be brittle. If they are far apart, material is said to be ductile. Note here. Brittle and ductile. Continuing. Let's see the problems. The stress strain curve for two materials A and B are given. Which is more ductile, which is more brittle? See, from the graph we can see that since D and E are far apart, this is a ductile, and here D and E are very closer, so it is what? Brittle. A is more ductile as a fracture point E and ultimate stress point D are away from each other. B is more brittle as the fracture point E and ultimate stress point D are close to each other. I hope that is clear. Then elastomers. Substance like tissue of aorta. Aorta is a tissue of aorta which carries blood from the heart, rubber, etc., which can be stretched to cause large strains are called what? Elastomers. Which can be stretched to what? Large strain. Large strain are called what? Elastomers. See, strain and stress. See, here stress is not proportional to strain. So, this substance does not obey Hooke's law. Hooke's law tells you that stress should be proportional to strain. Here, what is the problem? There is a large strain even for a small stress. So, it does not obey Hooke's law. These substances can be pulled to several times original length. Sorry, these substances can be pulled to several times original length, but what? Still returns to original size and shape. Stress strain curve. Although elastic region is very large, the material doesn't obey Hooke's law. Why? Because Hooke's law tells you that stress should be proportional to strain. But what is the problem with the elastomers? For a small stress, there is a large strain. So, it is not proportional. There is no well-defined plastic region. So, please note down elastomers. Please note down elastomers. Please note down these 2 points. Please note down this page. So, listen students, today we will continue the same class. Your next class is also physics. So, we will be continuing elastic properties of solids, but I am giving you a 5 minutes gap. Okay. So, please have some water and come. 5 minutes gap. Okay. Thank you. So, so note it down. Note it down. Stress strain curve for two metals. Clarity. Done? Is it done? Aaron noted. What about others? Please note it down. It's a previous Kerala board exam question. The question which you are noting down is a previous Kerala board exam. Noted, right? Then next problem. Not next problem. Elastomers. Elastomers. That is our next topic. What are elastomers? Small stress, large strain. Small stress, large strain. Small stress, large strain. This is stress. Y-axis we have strain. Does it obey Hooke's law? No. Because Hooke's law tells you that stress should be proportion to strain. But the problem with the elastomers is that stress is not proportion to strain. Small stress, large strain. Example, tissue of iota, rubber. Note ചെയ്താ? All of you done? Noted? Note ചെയ്താ? Next, modulus of elasticity. Different types of modulus of elasticity. See, modulus of elasticity. There are three types of modulus of elasticity. What are they? Let's see. There are three types of modulus of elasticity: Young's modulus, bulk modulus, then shear modulus or rigidity modulus. What is Young's modulus? What are the three types of modulus of elasticity? I hope you remember, because stress is directly proportional to strain. Stress by strain is equal to a constant. That constant K is what? Modulus of elasticity. It is of three types. What are they? Young's modulus, bulk modulus, then what? Rigidity modulus. First one, Young's modulus. Very important. Problem chodikya Young's modulus ആണ്. You can expect problems based on Young's modulus. Ratio of longitudinal stress to longitudinal strain is called Young's modulus. What is longitudinal stress? F by A. What is longitudinal strain? Change length by original length. So F by A into L by delta L. So this is equation for Young's modulus. Y is equal to FL by A delta L. This is the equation for Young's modulus, which is important. Since strain is dimensionless quantity, unit of Young's modulus will be same as stress, which is what? Newton per meter square or Pascal. Any doubt? Note here, no? Is Newton per meter square or Pascal? Young's modulus does, what is the unit of Young's modulus? Unit of stress only, because strain the no unit. So unit of Young's modulus is what? Newton per meter square or Pascal. I hope all of you done, because Young's modulus is a sure question, especially for entrance. Okay, let's continue. Let's continue. Yeah, since strain is dimensionless quantity, you want to, yeah. Okay. Now, if a wire has circular cross-sectional area, then what will be the equation of Young's modulus? If a wire has circular cross-sectional area, Young's modulus equation will be FL by, instead of cross-sectional area, we can write pi r square delta L. Now, next question. Young's modulus for a perfectly rigid body. For a perfectly rigid body, delta L will be what? For a perfectly rigid body, delta L will be 0. So, Young's modulus will be what? Either very high or infinity. Young's modulus will be very high or infinity for a perfectly rigid body. Next problem I will do. See, perfectly rigid body means what? Even after applying a force, distance between particles do not change. So, what is Young's modulus for a perfectly rigid body? Infinity or very high? Because delta L will be 0. 0 comes in denominator means what? Young's modulus will be very high or infinity. If wire is having circular cross-sectional area, then Young's modulus formula FL by pi r square delta L. None? Okay, continue. Next. So, what is the Young's modulus of a perfectly rigid body? Very high or infinity? So, continuing, we will do one problem. This is a problem. One end of a rope, one end of rope of 4.5 meter. What is the rope length? 4.5 meter. 4.5 meter, diameter 6 millimeter. See, is fixed to the branch of a tree. So let's see. This is the previous problem answer. So this is not required. Then we already saw one end of a rope of length what 4.5 meter and the diameter is what 6 millimeter. So radius will be diameter is 6 millimeter. So radius will be what diameter by 2. Radius is equal to what 3 millimeter. That is equal to 3 into 10 raised to minus 3 meter. Converting to SI unit. He fixed to the branch of a tree a monkey weighing 100 Newton. Weighing means what? Force is given 100 Newton. Jumps to catch the free end and stays there. Find the elongation. What is it by elongation? Elongation meaning is change in length. Elongation is equal to change in length is equal to delta L. It is delta L that we have to find out. Given Young's modulus is what? Young's modulus is 4.8 into 10 raised to 11 Newton per meter square. What is the formula for Young's modulus? FL by A delta L. And here what we have to find out? Delta L is equal to what? FL by AY. So delta L is equal to what is F? 100 Newton. What is the length? 4.5. Area is what? Pi r square. So pi into 3 into 10 raised to minus 3 the whole square into Young's modulus is what? 4.8 into 10 raised to 11. If you solve this, you will get change in length. Should be in meter. Please solve this. It's an NCERT textbook problem and it's also a previous Kerala board exam question. മക്കളെ ഡൗട്ട് ഉണ്ടോ? ആൻസർ ടൈപ്പ് ചെയ്യട്ടാ കിട്ടിയവര്. Please type your answer once you are done the problem. Yeah. 3.32 into 10 raised to minus 5, almost. Correct answer is 3.32 into 10 raised to minus 5 meter. 3.32 into 10 raised to minus 5 meter. It's an NCERT textbook question, previous board exam question. I hope all of you got that. If you didn't get that, please check it. Done. Finally. So continuing. Next year. Yeah. Next, shear modulus. The ratio of shearing stress to shearing strain is called the shear modulus of the material and is denoted by G, letter G. Shear modulus by letter G. G is equal to shearing stress by shearing strain. What is shearing strain? Tan theta, which is almost equal to theta. So shear modulus is equal to what? F by A theta, or F by A into 1 by theta, or F by A theta. Unit of shear modulus or rigidity modulus is Newton per meter square or Pascal. Why? There is no contribution from shearing strain because strain has no unit. Dimensional formula ml raised to minus 1 t raised to minus 2. For most of the material, shear modulus is equal to Young's modulus by 3. Note it down. For most of the material, shear modulus is equal to Young's modulus by 3. For most of the material, shear modulus is equal to Young's modulus by 3. Next, shear modulus. Next, we will do this problem. Again, textbook problem. An edge of the aluminum cube is 10 centimeter long. An edge of the aluminum cube is 10 centimeter long. One face of the cube is fixed to a vertical wall. Suppose this is the vertical wall and this is the aluminum cube. Its one side is 10 centimeter long. And what happens? A mass of 100 kilo is then attached to the opposite face. So this side a mass of 100 kilo is attached. It is not weight that is given, it is mass that is given. The shear modulus of aluminum. What is shear modulus? It is what? G. G is equal to, G is given what? 25 into 10 raised to. So length is what? 10 centimeter. That is length is equal to 0.1 meter. Mass is what? 100 kilo. Shear modulus G is equal to 25 gigapascal. You should know giga means 10 raised to 9. So 25 into 10 raised to 9 Pascal. Okay. What is the vertical deflection of the face? They are asking for vertical deflection. See, due to this weight, there will be vertical deflection. It will be bending. This delta x you have to find out. We know that what is shear modulus? Shearing stress by shearing strain. What is shearing stress? Force by area. What is shearing strain? Tan theta, that is almost equal to theta, F by A theta. What is equation for shearing strain? It is delta x by L, that we know, delta x by L. So what is the formula for shear modulus? F by A into, instead of theta you can write delta x by L. So F by A into L by delta x, that is FL by A delta x. So what is the data we should know? Delta x. All other data is given. Force is what? 100. No, force is not 100. Mass is 100. Force is what? Mass into gravity. So force is what? 100 into 9.8 into length is what? 0.1 divided by area is what? Since it is a cube, area is what? A square, side into side. So 0.1 into 0.1 into shear modulus is what? 25 into 10 raised to 9. If you solve that, you will get the answer. Delta x is equal to 3.92 into 10 raised to minus 7 meter. Doubt now? 3.92 into 10 raised to minus 7 ആണ് ആൻസർ. ഡൗട്ട് ഉണ്ടോ? അതോ സെപ്പറേറ്റ് ചെയ്യണം? ഞാൻ ചെയ്തിട്ടുണ്ട്. ഡൗട്ട് ഉണ്ടോ? നോട്ട് ചെയ്യാടാ. ഡൗട്ട് ഇല്ലാന്ന് ഇരിക്കുന്നുണ്ട്. ഡൗട്ട് ഉണ്ടെങ്കിൽ പറയണേ. If you want to repeat, please ask me. Please type. I will repeat. നോട്ട് ചെയ്യട്ടെ എല്ലാവരും. കഴിഞ്ഞ all of you noted? Done. Next topic bulk modulus. Next topic bulk modulus. Let's see bulk modulus. The ratio of volume stress to corresponding volume strain is defined as bulk modulus. It is denoted by B. What is B? Volume stress to volume strain. F by A by volume strain is what? Delta V by V. What is F by A? Pressure. See, there is a minus sign. Why there is a minus sign? The minus sign indicates that with increase in pressure, there will be decrease in volume. What is the equation for bulk modulus? It is volume stress by volume strain. What is volume stress? Volume stress, we know that it is what? F by A. What is volume strain? Delta V by V. But in the final answer, why there is a minus sign? If we increase the pressure, there will be decrease in volume. If pressure is positive, there will be decrease in volume. If pressure is negative, there will be increase in volume. If pressure is reduced, what happens? Volume is increased. If pressure is increased, volume is decreased. So that is the reason why there is a minus sign. Note down bulk modulus. എല്ലാവരും ബൾക്ക് മോഡുലസ് നോട്ട് ചെയ്യുക കേട്ടോ. Next, compressibility. Next topic is compressibility. Let's see compressibility. The reciprocal of bulk modulus is called compressibility. What is compressibility? Reciprocal of bulk modulus is called what? Compressibility. So compressibility denoted by letter K. K is equal to reciprocal of bulk modulus. K equal to 1 by V. So K equal to what? Minus delta V by PV. SI unit is what? Pascal raised to minus 1 because it is reciprocal of compressibility, or meter square Newton raised to minus 1. Dimensional formula m raised to minus 1 LT square. The bulk modulus of solids is what? Much larger. Why? Compressibility, bulk modulus are inversely proportional. So lesser the compressibility, more will be bulk modulus. See, solids are least compressible. So bulk modulus will be what? Very high. The bulk modulus for solids is much larger than that of liquid, which is again larger than bulk modulus for gases. The solids are what? Least compressible, whereas gases are most compressible. So bulk modulus of solids. So I am thinking bulk modulus and compressibility is what? Inversely proportional. Solids are least compressible, so bulk modulus maximum, which is greater than bulk modulus of liquids, which is greater than bulk modulus of gases. So I can write compressibility of gases, compressibility of gases greater than compressibility of liquids, greater than compressibility of liquids, which is in turn greater than compressibility of solids. So solids the least compressible, so bulk modulus maximum. Gases maximum compressible, so bulk modulus minimum. Please note it down. Note ചെയ്തില്ലേ എല്ലാവരും? So let's continue. Yeah. Continuing. Which is more elastic, steel or rubber? Steel is more elastic because it has what? Greater Young's modulus. Always remember, higher the Young's modulus, more elastic, more stronger. Higher the slope of stress strain graph, higher the slope of stress strain graph, the more elastic the more Young's modulus, the more stronger the material would be. The more stronger the material would be. So the more the slope, what happens? More will be Young's modulus. More will be what? The stronger the material, the more will be elastic. More will be Young's modulus. Okay. So what is the Young's modulus of and approximate yield strength of the material from the figure? So what is angle here? 60. What is Young's modulus? Slope of stress strain graph gives Young's modulus. So Young's modulus equal to slope, that is equal to tan theta, that is tan 60. But here there is a point. Stress is in the unit 10 raised to 10 Pascal. Stress is in the unit 10 raised to 10 Pascal. So what is the Young's slope equal to what? Tan 60. What is tan 60? Root 3. But you should multiply root 3 into 10 raised to 10. Because y-axis, the stress is in 10 raised to 10 Pascal unit. So that is the reason why root 3 into 10 raised to 10 is done. So what is the answer? 1.732 into 1.732 into 10 raised to 10 Pascal. Always remember, slope of stress strain graph is what? Young's modulus. Slope means what? Tan theta. Angle is given 60. So tan 60. Tan 60 is what? Root 3. Then why we are multiplying into 10 raised to 10? Because stress is in the unit of 10 raised to 10. Is having the magnitude 10 raised to 10. Any doubt? No doubt now. Which is more elastic, steel or rubber? Between steel and diamond, which is more elastic? Diamond. Diamond is almost a rigid body. Elasticity is extremely strong. More elastic, the more rigid also. So if you note this, it will be helpful for you. If you note this, that is written with the green ink, it will be helpful for you. So slope of stress strain graph is what? Young's modulus. The more the slope, more elastic, more rigid, more stronger, more Young's modulus. നോട്ട് ചെയ്താ. Yeah, next point is Poisson's ratio. Next topic is Poisson's ratio. Poisson's ratio. When a wire is subjected to extension along its length, there will be contraction perpendicular to length. Suppose there is a wire. Here there is a wire. I am applying a load to the wire. So what happens? When you apply the load, what happens? There will be contraction perpendicular to the length and extension along the length. See, because of the load, the wire has extended its length along the length, but contraction perpendicular to the length. When a wire is subjected to an extension along its length, there will be contraction perpendicular to the length. This is perpendicular to the length. Here wire contracts, but here what at the ends they wire extends. അല്ലേ? സി സാറിന് ഈ ഓണത്തിനൊക്കെ എൻ്റെ വീട്ടിൽ കയറുമ്മ കായക്കൊല ഞാത്തിയിടും. ആ കായക്കൊല ഇടുമ്പോൾ കയറിന്റെ മിഡ് പോർഷൻ ചുരുങ്ങും, കോൺട്രാക്ഷൻ, and the extend and the end will get extended. The strain perpendicular to the applied force is called lateral strain. Strain parallel to the applied force is called longitudinal strain. It's very important. Strain perpendicular to the applied force is called lateral strain. The strain parallel to the applied force is called longitudinal strain. Within the elastic limit, the lateral strain is directly proportional to longitudinal strain. The ratio of lateral strain to longitudinal strain is called Poisson's ratio. It is a ratio of two strains, so no unit. It's a pure number. It has no units, no dimensional formula. For steel, the value is between 0.28 and 0.3. For steel, the value is between 0.28 and 0.3. So this ratio is called what? Poisson's ratio. When a wire is subjected to extension along the length, there will be contraction perpendicular to the length. The strain perpendicular to the applied force is called lateral strain. The strain parallel to the applied force is called longitudinal strain. Within the elastic limit, lateral strain is directly proportional to longitudinal strain. Ratio of lateral strain to longitudinal strain is called Poisson's ratio. It is a ratio, it is a pure number, it has no unit, no dimensional formula. For steel, its value is between 0.28 and 0.3. നോട്ട് ചെയ്യട്ടോ, പോയ്സൺസ് റേഷ്യോ. ഡൺ. നോട്ട് ചെയ്താ? നോട്ട് ചെയ്താ? ഡൺ. Yeah, next. Next, there are certain things to be noted. What is shear modulus of liquid? Shear modulus of liquid is 0 because liquids are least compressible. What is rigidity modulus of liquid? That is also 0. Please note down, you can expect this in one word and also entrance. What is shear modulus of liquid? 0. What is rigidity modulus of liquid? That is also 0. Shear modulus of liquid is 0 and the rigidity modulus of liquid is also 0. Shear modulus and rigidity modulus both are same. liquids does not have a definite shape. So this change in shape is not applicable to them. So shear modulus of liquid is 0. Liquids does not have definite shape. Liquids does not have definite shape. Shear modulus of liquids is 0. Liquid does not have definite shape. Remember, shear modulus and rigidity modulus both are same. Shear modulus and rigidity modulus both are same. Note that shear modulus and rigidity modulus of liquids are 0 because shear liquids does not have definite shape. So students, I am stopping now. Next class we will be continuing. Next class topic is application of elasticity. So thank you all. Thank you. Good night. Thank you.